In video 2 of this lesson, we'll be looking at how to find inverse functions algebraically. Now, in video 1, we discussed the idea that a function and its inverse have switched inputs and outputs. So fortunately, that gives us a pretty easy way to find inverse functions. We can just switch x and y, and then resolve for y so that it looks like that's our output again. So if we look at a real example that we can pretty much already know the answer to, right? How do you undo adding 5, you subtract 5? We can kind of do a proof of concept here. So the first thing I'm going to do is replace f of x with y, just to use some simpler notation. And then, like it says in the steps up there, we will swap x and y. So instead of y equals x plus 5, we'll have x equals y plus 5. Now all we have to do is solve for y, and we'll have our inverse function. So to solve for y here, the easiest way to do it is subtract 5 from both sides, which will give us x minus 5 equals y, which last step is just going to be to rewrite it using our new notation. So f inverse of x equals x minus 5. So now we have the inverse function of our original function. Look at a slightly more complicated example here. It's going to take us a few steps. So first we're going to change our notation to use y instead of fx. Y equals 3x minus 2, all divided by 5. And now I want to swap x and y so that we can resolve for y for the inverse function. So x equals 3y minus 2, all divided by 5. And to solve for y, the first thing I have to do is multiply both sides by 5. We'll get 5x equals 3y minus 2. And we'll add 2 to both sides, giving us 5x plus 2 equals 3y. And last thing to do is divide both sides by 3. So we will get 5x plus 2 divided by 3 equals y. So again, now we just rewrite in our new notation, f inverse of x equals 5x plus 2 divided by 3. And there is the function that undoes our original function.